Yesterday we had seen force, resolution of force, composition of force, system of forces, resultant of forces, how to represent resultant of force, magnitude, direction, position, etc. We have taken one example also. Now today onwards. First, Dnyandeep principle. Consider three forces acting at a point O. Let it be phi, Q and R. If angle between Q and R is alpha, between P and R is beta, and between P and Q is gamma, then as per Dnyandeep's principle, P upon sin alpha equal to Q upon sin beta equal to R upon sin gamma. That is, in statement, each force is proportional to sine of angle between other two forces. P is the force, these two forces have angle alpha, so sin alpha, P upon sin alpha. Q is the force, opposite to that forces are P and R, angle is beta, so Q upon sin beta. R is the third force. Two forces other than R are P and Q, angle between that is gamma, so R upon sin gamma. So P upon sin alpha equal to Q upon sin beta equal to R upon sin gamma. Now this is the D'Alembert principle. But what is its use? We will say this principle is alright. But what is the use of that? Suppose if you are given force P, if you are given force Q, and if you want to find third force R and angles between these forces alpha, beta, gamma are given, then apply the D'Alembert principle, P upon sin alpha, Q upon sin beta, R upon sin gamma. In between, in all this equation, P is known, this is known, this is known, this is known, this is known, but this is not known. So R can be found. Or like that, P may be found if it is asked, Q may be found if it is asked. Sometimes alpha may be asked, that can be found. Sometimes beta may be unknown, that can be found. So this D'Alembert's principle is used to find out of three forces, if two are given, or out of three angles, two angles are given, and so on. Next, very important, moment theorems. There are two moments of theorems. Two theorems are there in number about moment. Now before that, what is moment? Consider a force point O. Consider a force P. If x is the perpendicular distance between point O to force P, then moment is m given by P into x. So what is the unit of moment? Unit of force is N, Newton. Unit, this is distance. So Newton meter. Sometimes it may be Newton centimeter or whatever it is. Next, we will see what are the theorems of moment. Now, first theorem of moment. First theorem of moment. It is, consider a point O. First, before that, I will give you the statement. First theorem of moment statement says, if the system is in equilibrium, then summation of moments of all forces about a point is equal to moment of resultant. Once again, if there are number of forces and considering a point O, once again statement, summation of moments of all forces about a single point is same as or equal to moment of resultant. Considering, suppose there are different forces, its explanation P1, P2, P3, P4. Whereas after finding resultant by the previous theory, suppose R is the distance, R is the resultant. Then according to this theorem of moment, now if distance between point O and every force, if are x1, x2, x3, x4, and if, to be precise, if distance from O to resultant is D, let us take D to avoid confusion, then theorem of moment in this case will be P1 x1 plus P2 x2 plus P3 x3 plus P4 x4 is equal to, what is the right hand side? T is equal to R into D. Summation of moments of all forces about a point, about O, is equal to moment of resultant. Here x1 is the perpendicular distance from O of force P1, x2 of P2 and so on, x3, x4. Whereas for R, resultant, its perpendicular distance is from point O is D. So P1 x1 plus P2 x2 plus P3 x3 plus P4 x4 is equal to R into D. Left hand side summation of moments, right hand side moment of resultant. This is first theorem of moment. Next is second theorem of moment. What is second theorem of moment? First statement. Again, in system of forces which is in equilibrium, summation of clockwise moments equal to summation of anti-clockwise moments. Now before that, what is clockwise moment, anti-clockwise moment? Consider a point and consider a force. Suppose P is the force, O is the point. What is the and x is the distance. What is the moment? Moment is P into x. And what is the direction of moment? Whether it is clockwise or anti-clockwise. For that, consider a point, consider the force, and consider how that moment is acting, or what is the rotation. Is the rotation or the direction of movement in this case you will find is like this. Like this means what? It is given name clockwise. How clockwise moves? In this direction. 12, 3, 6, 9, 12. Right? So this is called as clockwise movement. Consider other case. Suppose O is a point and force is like this instead of like this. Suppose P is the force, X is the distance. Now what is the moment? P into X. But what is the rotation or what is the moment direction? If you consider point O, for that, for understanding, I will explain. I will suggest take a point and put one finger on that and see how the rotation due to moment takes place. Here the rotation is like this. Now what is the direction of moment in this case? Direction of moment is in this case, here first was clockwise. Now in this case, how it is? It is anti-clockwise. Clockwise movement, anti-clockwise. So if any force is acting and considering a point O, you first see how the moment due to that force about a point is acting, whether it is clockwise or anti-clockwise. That you first understand. Again, in other case, whether that moment is clockwise or anti-clockwise. If anti-clockwise is there, it should be like this. Is this clear? If this is clear, then we will little bit in explanation see what is theorem of moment. Now this theorem of moment is like this. Summation of moments which are in clockwise direction. Summation of moments of forces, not moment. Summation of moment of forces or forces about a point in clockwise direction according to the theorem is equal to summation of moments of all forces in anti-clockwise direction. These moments are clockwise. These moments are anti-clockwise. For explanation, consider a point. Consider different forces. Any number of forces. Consider a point. Now I am not telling you what is the force, what it is the distance from point, etc. Now I will explain which is more important in this case is which force is causing clockwise movement, which force is causing anti-clockwise. After that you can calculate, you can write the equation, etc. But first see which force causing clockwise movement. Now this force about point, if you take moment, whatever is the distance, P into X, etc., is clockwise. This force, whereas if you consider this force and its moment about this is anti-clockwise. Again this force causing moment clockwise. This force moment causing about anti-clockwise. This force causing moment, once again see, if you don't understand, if anybody of you don't understand, extend the line of action of force. Sometimes what happens, force is here and how to find the moment, for that extend the line of action of force so that you can easily understand what is a moment and how it is acting. Now here, in this case, moment of this force about this is force into distance. This is the distance, whatever it is, x, y or z. Now this force causing moment, which is force into perpendicular distance in anti-clockwise direction. So summation of moments of clockwise direction, clockwise moments, summation of moments anti-clockwise. So this moment are clockwise, whereas this moment due to force is anti-clockwise. This also is clockwise. This also is anti-clockwise. This is anti. So this is anti-clockwise moment. This is anti-clockwise moment. This is clockwise moment. This is anti-clockwise moment. This is clockwise. Now force, perpendicular distance, taking moments, that you know. That is not need not be explained. That you have understood. The theorem you should understand. What is clockwise moment? What is anti-clockwise? So when a system of forces is given, your work is to find all moments which are in clockwise direction. Add that. See all forces which are causing anti-clockwise moments. Add that. And make the equation summation of moments of forces causing clockwise on left hand side and summation of moments of all forces causing moment on right hand side and equate. If you equate, you will get